Assalamualaikum everyone. First of all, I would like to thank the organizing committee of ICAZ 2022 for giving me the chance to present my research topic as an hour presenter. I am Ayesha Khizer from Department of Fisheries and Aquaculture, University of Veterinary and Animal Sciences, Lahore, Pakistan, and my topic of discussion is interactive effect of vitamin C and E on growth, lipid peroxidation, blood chemistry, and survival of silver carp. Minerals and vitamins are important micronutrients which are required for the maintenance of normal body functions. Vitamins are organic compounds which are required in the diet for optimum functioning of animals, including fish. Vitamin C and E are two widespread antioxidants which are widely used in the fish food for stress reduction and immunity boosting. The importance of vitamin C in fish is important due to they enhance the immunity, growth, and health status while reducing the stress. It helpful in collagen synthesis and bone matrix, while the deficiency of vitamin C in fish causes dysfunction of biochemical processes, reduced growth, health, and immunity, while stress level increase. The importance of vitamin E in fish show positive response on growth, performance, health, and resistance against stress. It also protects cell membrane and from free radical oxidation. The deficiency of vitamin E causes hemolysis, distortion of red blood cells, and reduced survival rate. The interaction of vitamin C and E is important as both vitamins are necessary for health and growth and have antioxidant property. Vitamin C has sparing effect on vitamin E. It has ability to regenerate vitamin E and both synergistically improve the production of antibodies in fish. Silver carp Hypophthalmictis molitrix is a freshwater species and mostly cultured in polyculture with catla and other major carps. It feeds on phytoplankton, detritus, and feed waste. It contributes to the maintenance of water quality and mostly cultured under extensive aquaculture system, and no comprehensive information is available on its feed formulation, particularly use of vitamins in the feed of fish, as the growth rate and survival of silver carp is high in wild as compared to farmed fish. To improve the health status of farmed silver carp, supplementation of vitamin E and C is necessary in feed. So this study should be beneficial to improve the health status of silver carp and to enhance the economy of farmers. The objectives of this study is to estimate the feed efficiency and growth performance of silver carp, to determine the proximate composition, antioxidant enzymes activity, and lipid peroxidation status of silver carp, to check the status of vitamin E and C on survival rate, fed silver carp after challenged by Arominas hydrophila. The research work was carried out in Fish Seed Breeding Unit, Department of Fisheries and Aquaculture, Shuvas Travel Campus, C Block, Patoki, and the composition of experimental diet is described here, in which the ingredients fish meal, soybean meal, canola meal, wheat flour, rice porridge, fish oil, vitamin premix, which is C and E free, vitamin mineral mixture, lysine, methionine, monocalcium phosphate ingredients were used in the diets, and 6 experimental diets were made in which ascorbic acid and alpha tocopherol were used as a source of vitamin C and E. The two sources of vitamin E, C, and three sources of vitamin C and two sources of vitamin E were used in the study, and the experimental layout is described here, in which the diets were formulated and first of all, and dry ingredients were mixed. After mixing of dry ingredients, dough was formed and pellets were formed after dough formation. When pellets were formed dry, the pellets up to 1% moisture and stored in self-clean bags. The in-fish husbandry fingerlings were acclimatized and after for 15 days, and 25 fish stocked in each replicate. Fish fed with diet twice a day, and physical chemical parameters were kept constant and continued for 60 days. In challenge trial, after 60 days of feeding trial, 10 fish formed from each treatment were harvested for analysis, and remaining 15 fish were challenged with Aramina cytophila. Survival rate was observed after 10 days. The analyses which were performed during the study are growth performance, body indices, proximate analysis, hematological parameters, antioxidant enzymes activity, and tabaxis, serum biochemistry, deposition of vitamin C and E, concentration in liver and diet, and survival rate after challenge with Arominas hydrophila. The results are described, in which the growth performance showed maximum result in terms of final weight, average weight gain percent, survival specific growth rate, feed intake, FCR and SGR. The maximum growth performance was observed in T4 diet comprising of 250 mg per kg vitamin C and 100 mg per kg vitamin E. Feed intake and SGR and survival rate showed non-significant results in the study. The proximate analysis showed here in terms of moisture, crude protein, crude fat, and ash percent. Moisture and ash showed non-significant results, and crude protein and crude fat showed significant results. The maximum result observed in T4 diet having vitamin C 250 mg per kg and vitamin E 100 mg per kg. The body indices in terms of hepatosomatic index and histiosomatic index is described here, and the significant results were shown in terms of hepatosomatic index, and the highest result observed in T2 diet comprising of zero concentration vitamin C and 100 mg per kg level in vitamin E. In hepatosomatic index, non-significant results were observed, and showed that the results was maximum in diet comprising of T4 and T6, while the antioxidant enzymes activity was determined in terms of SOD, CAT, GPX, and TABARS. The SOD activity was show and CAT activity was maximum in T6 diet comprising of vitamin C 500 mg level and vitamin E 100 mg per level, while the GPX activity was maximum in T4 diet comprising of 250 vitamin C level and 100 mg per kg vitamin E level. The Tabars assay showed maximum result in T1 and T3 diet. The hematology results were explained and the platelet counts were observed maximum in T1 and T3 diet, while hemoglobin showed maximum result in T4 diet. The red blood cells hematocrit showed also maximum result in T1 and T3 diet, while the white blood cells MCHC showed maximum result in T5 diet, similar to glucose, which is also maximum in T5 diet. The liver vitamin C and E concentration was determined, and the maximum result of vitamin E in liver concentration showed maximum result in the diet comprising of vitamin C vitamin C having the 0 level and vitamin E having 100 level T2 diet, and T4 diet and T6 diet. T4 diet comprising of 250 vitamin C level and 100 vitamin E level, while T6 comprising of 500 vitamin C and 100 mg per kg vitamin E level. The vitamin C in liver concentration showed maximum result in T5 diet comprising of 500 mg per kg level vitamin C and 0 mg per kg level vitamin E. The serum biochemistry were determined in terms of ALP, alkaline phosphatase activity, amino aspartate, amine transferase activity, and ALT. The maximum result of ALP was shown in T4 diet. ALT showed maximum result in T1 and T3 diet, while the ALT-ST showed maximum result in T2 and T6 diet. The survival rate challenge after arominacytophilia showed maximum result in T4 diet comprising of 250 vitamin C and 100 mg per kg vitamin E level. In conclusion, the research data suggested that vitamin C and E supplementation in feed enhanced the growth status of silver carp. Supplementation of these vitamins improved serum biochemistry and immunity against bacterial infections. Supplementation of vitamins comprising of 250 mg per kg vitamin C and 100 mg per kg of vitamin E showed positive response in the health of silver carp. Thank you for your kind intentions.